Welcome to this first video of my channel. I'm the PC Collector. If you are here is because you like old computers or tech, or simply you want to see someone fighting with a decades old computer. In any case, you're welcome. In this video I'm going to do a project which I've been wanting to do for quite a while, and in which I'm going to restore a Pentium Pro, an old computer produced between the years 95 and 98. If you have reached this far, likely you already know what a Pentium Pro is, but if you don't, I'm going to explain you very shallowly what it is. This part was redone in edition because I realized that I didn't like how the original part had turned out. So the Pentium Pro was designed as a sort of replacement for the original Pentium, but targeted to servers and high-end workstations. It was designed in collaboration with Microsoft and was focused on the 32-bit software execution, because at that time it was believed that both Windows 95 and Windows NT were going to be full 32-bit. But we all know that ultimately didn't happen, and Windows 95 ended being hybrid. This generated a problem because the 16-bit execution had been forgotten, sort of, and as a result of that and other flaws of the CPU, the Pentium Pro turned out to be outperformed by same clock speed normal Pentium processors on 16-bit software execution, around 5 and 10% slower, which, coupled with a very high production cost and thus a very high retail price, caused that it sold very poorly and was seen as a market failure. While the Pentium Pro had a completely different architecture compared to the Pentium, the most noticeable difference was the inclusion of the on-die cache level 2 memory, which increased dramatically the performance alone, since the cache could communicate directly with the CPU at full speed without requiring an external boost, which was much slower, as it happened in older CPUs. This imposed a severe size limitation on the CPU itself, which became massive because memory chips at that time were huge. But on the other side, that internal architecture made the Pentium Pro to outperform every other CPU on the market in multi-CPU configurations, which were common for high-end workstations and servers. However, that also caused a very costly and difficult production process, since the core of the CPU and the cache had to be linked much before the CPU could be tested. That meant that if the connection failed, the processor couldn't be repaired and had to be completely discarded, which made production more costly and contributed to the high price and poor sales of the CPU. Originally, the CPU was offered in 4 versions, as shown in the table. It isn't clear why Intel decided to offer a version with a 60 MHz boost which was already considered suboptimal for the time in a high-end targeted CPU. In fact, the 60 MHz bus CPUs were reported to be unstable, as they clearly weren't designed to work at that speed and were frequently overclocked to work with the 66 MHz bus, increasing stability and performance. However, since clock speed didn't significantly affect the production cost, the 150, 166, and 180 MHz CPUs were quickly discontinued, and the only which was producing significant numbers were the 200 MHz version. However, although the CPU was considered a complete failure on the general market, being shadowed by the Pentium MMX launched in January 1997 and completely kicked out of the market by the Pentium 2 launch on June of that same year, the CPU continued to have a good reception on the server market and in fact remained in production until June 1998, when it was replaced by the Pentium 2 Xeon. It is worth noting that even if the CPUs were only offered with 2.5 and 3.0 ratios, the Socket 8 boards also allowed to use 2.0 and 3.5 ratios, although only the 200 MHz version could use the 3.5 ratio in a stable way. The board I'm going to use is this Intel Venus board, which is one of the most basic Socket 8 boards, and it is a full ATX board as can be seen. It has 8 expansion slots, 4 PCI slots and 4 ISA slots, but only 7 of them can be used as the 2 in the middle share a slot. The board uses 72-pin Edo RAM modules, which means that although the board supports up to 512 MB of RAM, I can only go as high as 128, merely because I don't have bigger Edo modules. Here we can see the front panel connectors. Yes, I know, they're bent. They were already like that when I got the board. And the ID and floppy connectors, which don't have any kind of socket, so that means that they're tricky to get plugged on properly. For expansion cards, I'm going to use a Matrox Millennium as video card. I know it's not exactly stellar, but is unfortunately the better I have available with a PCI connection. For sound, the choice is this Sound Blaster Live card, which isn't period accurate for the machine, but it will do the work since it has Windows 2000 drivers, which is what I'm going to use as an operating system. As optional cards, I'm going to use this USB card because it's a shame to not have USB on Windows 2000, and this ISA network card, mostly because why not, because I had it around and had no other use for it. As the case to assemble the machine, I'm going to use this case I have free after the original machine inside it died a few months ago. This is the typical cheap ATX case you could find in the late 2000s, and well, it already has the optical drive and the floppy drive on it, and also has the supports for the board already installed, which will make it easier to assemble or not, because each support is different, so we will see. And well, we have our board installed in the case. Although it is not absolutely necessary, it is advisable to install all the supports and all the screws that the board has holes for it, because if you don't do that, it is quite easy that you can bend the board when installing the rest of the components, like the cords of the cable or the cables, and you can easily damage the board if you flex it too much. And now I'm going to get some extra light so I can properly plug the front panel connectors, because without some more light I'm not going to see anything to do it. And now it's time to start installing the expansion cards. Now I'm going to put the video card on the first slot. This is a personal custom. You can put the cards pretty much on any compatible slot and they are going to work exactly the same. In the second slot, I'm going to place the USB card, which has got stuck. That happens a lot on that kind of cards. They are kind of tricky to install properly. And on the last slot, I'm going to put the sound card. That's another personal custom from the time in which the ICE sound cards were enormous. and the only way to place them in a way that they won't be in the way we're placing them on the last slot. But on that last slot, on that last ISA slot, I'm going to slap the network card. Yeah, just like that. And we are done. Now it's time to screw in the cards. It is important when you are installing cards on a computer, no matter if it is new or old, that you don't force the cards in. While in some cases the slots can be hard and require some force, especially in the case of the ISA slots. If you need to force them in, probably you are not installing them properly. So be cautious with that. Mainly because the card isn't properly installed, it can happen that it doesn't make contact and thus it doesn't work, or it can even damage the card or the motherboard itself. So yeah, be very cautious when installing a card on a system. And we are done installing the cards. And this is how the computer looks with all the cards and the power supply unit installed. And now we are going to start connecting the power connectors to the computer itself. First, I'm going to connect the ATX port, which, in case someone doesn't know, is where the motherboard gets their power from. And this little connector here is the one from the CPU fan, which can be connected pretty much wherever we want. So it will be connected to any free connector I have at the end. Now I'm going to plug in the floppy drive. I've said I'm going to plug in the floppy drive, which doesn't want to get plugged in. Okay, now it's done. And these two here, I'm going to use them to connect the optical drive. And now I'm going to get to the not so easy part, which is connecting the data cables to the board. As we mentioned before, those cables can be connected either way due to the lack of the socket for the connectors. But if you look here at the IDE connector, you might notice that there's a pin missing. That is because early cables had that pin covered in the cable itself, so you knew how to properly plug it in. And that missing hole is in the opposite side to the notch that the IDE cables have for the socketed connectors, which in this case tell us that the IDE cable has to be connected with the notch to the front of the computer. That's useful because the floppy drive cable usually matches the same direction for the connection. I'm back to tripod mode because I need both hands to connect the cables on the board. First, the floppy drive cable. Since these connectors don't have any kind of socket, you have to be very careful because it's very easy to connect them improperly or leave pins out of the connector when you connect the cable. And now we are going to connect two IDE cables, one for the hard drive and other one for the optical drive. This is not necessary, we could use only one cable for both, but I find easier to do the connections using two separate cables for hard drives and optical drives. That's mainly because the optical drives are, if you have more than one, they're usually closer one to each other, and the same goes for hard drives. So that makes it easier to connect them if you have more than one of each. Now, well, we have spoken about hard drives, but we are not going to use any hard drive on this machine. We are going to use this little thing. This is an SD to IDE adapter which allows to use an SD card as a hard drive. This is suboptimal, but well, the ideal thing would be to use a compact flash adapter, but those are much more expensive than SD adapters, and so are small compact flash cards. If you are using a computer modern enough so it can use a drive big enough for a compact flash to be worth, you'd be better using a SATA to IDE adapter instead and use a normal SSD instead. These ISD adapters have this small problem with the contacts making having all the contacts with uncovered. So when with the chassis, place them on your machine, you have to be careful so you don't short the board. I'm going to attach it to this part of the chassis, taking advantage of those holes on it and using supports similar to the ones used to attach boards to the chassis itself. I'm going to place it there for convenience because having the SD card reader there allows me to quickly change the card if I wanted, but you can place it pretty much anywhere where the supports could be screwed on the case. However, if you don't value the ability to change the card on the fly, you can use some cases that are made for those things, which allows you to screw them directly on 3.5-inch base. But I want to be able to change the card if needed, so I'm going to place it here, and that's why I'm going to use those smaller supports so they keep the adapter apart from the metallic surface of the chassis, and I can connect it easily. You'll have probably noticed that I'm screwing them by hand, since those drives don't have any kind of mechanical part. It's not as important as with hard drives to keep them firmly attached to the chassis. So as long as it won't fall is enough. And now I have to change the cable I'm used to give the power supply to the floppy drive, because otherwise I won't have a cable long enough to feed the SD adapter. So let's swap it. And with that, I'm done with the physical part of the assembly of the computer.